In this video, I'm going to show you how to create visuals in a web-based application called CODAP, stands for Common Online Data Analysis Platform, whose precursor was called Tinkerplots, which was created for use largely by middle school students. And I use this platform a lot in initial doctoral courses where students may have high anxiety about doing statistics if they haven't done it in a long time, or maybe they've never actually done it before. And so this is a great platform to use to get students acquainted with things. And at some point, you might be wanting to move them towards a more common platform that's used by professionals who do statistics, such as SPSS or perhaps R. And in this particular video, I'm going to show you how to recreate some of the same ideas, visuals that are being used in CODAP that are really nice to help showcase some of the more conceptual perspectives of the statistics that are being calculated in R. And I hope that you find it useful. So one of the really cool things about CODAP is that you can create things really simply using drag and drop features, clicking on buttons. It's much more simple than SPSS, and of course a lot more simple and less technical than using a programming-based environment like R. And here I've got some data. I've collected data over several semesters using doctoral students, undergraduate students, master's students, teachers, where I have them open mini boxes of raisins and count how many are inside, and also make predictions of how many they think are going to be inside of it, and ask others how many they think might be in there. So for this particular video, I'm just going to be using the actual number of raisins, and the question that we would explore with this would be something like, what is the typical number of raisins in a box? And so the first thing I want to show you, though, is that one of the neat features is the way that graphs are created or visualizations are created in CODAP. I just click the graph button, it throws it up there, and then we can just grab the word actual here in this case and drag it down here to the horizontal axis or the x-axis, and it forms it into a nice dot plot where we can see center, spread, and shape pretty easily. You can see all of the data points individually, which helps develop that conceptual understanding of what's happening when you're looking at center, shape, and spread. And then, of course, there's lots of layers that we can add to this. So, for instance, in this case, clicking on this ruler gives us several things we can add. We could add the mean, the median to this, which just adds these red and blue lines. So the red line is the median, the blue line is the mean. We could also go in here and add the standard deviation, for instance, which adds it as this range. So if I hover over this, it shows plus or minus 1 standard deviation, which in this case is a distance of 3 raisins, a difference of 3 raisins on either side. We could also add the mean absolute deviation, which is something that's common to be used as a precursor to standard deviation in the middle grades. And we could also add a box plot and overlay that on top like this. And so this was really simple to do just by checking some boxes. But let's say you're doing something more complicated, and so you're already using R, but it'd be nice to be able to show this kind of thing. And I show you this to show you also the power of R in being able to produce really nice looking graphics. And so in order to do this in R, we do have to use one package, but I'm going to use base R as much as possible. So to start off, in order to do this in R, the first thing that you need to do is load the data in. So you can import the data using base R using this read.csv function. And what you need to put in here in quotation marks is the actual file path to the data set, which ends here, and then the name of the actual data file with the file extension, in this case .csv. After you do that, we're going to use this little backwards arrow looking symbol. In a lot of programming language, you would use the equals symbol. That's considered bad form in R, and this means like store into. So we're going to use this pointing to the letter D is what I'm going to use. You could type anything you want there, pretty much. And so it's going to store the data set in the letter D. And so once we do this, it will load it. You'll see down here in the bottom in the environment, it shows D, 70 observations of 3 variables. And so if I type names, and in parentheses put the letter D, it will show me the variable names of this data set. And if I click on this, you'll see why it's showing X as the first one, because I've left this first column in here. And I did that intentionally because I wanted to also show you how we can pretty simply subset the data. So let's say we don't want that there. We could just ignore it if we wanted to. But we could just simply tell R that we don't want that column. So I'm going to overwrite D, so store into D, and in R we use brackets when we're calling columns and rows of a particular data set or data frame. In this case, we don't want to deal with rows. Rows is the first argument we would put in. So if we wanted to, for instance, only look at the first row, we could type in a 1 here as the first thing. We're going to just put a comma and leave it blank. And then for the columns, we're going to tell it we only want columns 2 to 3. And colon means everything between the number on the left side and the number on the right side of the colon. And that will take all of that out. And so now if I type in names of D, you see that the X variable has disappeared. If we reopen the data set, you'll see that we just have actual and predicted there now. Okay, so we could create some plots of this pretty easily in R. A dot plot is actually a little bit complicated to do in R, but we could easily create a histogram. So HIST is the function, and use the $sign to tell it we want a specific column or variable. In this case, we're going to choose actual. You can click on it or press tab and it will select it for you. And then I'm just going to click Command Enter to run it. You can also click this button up here to run it. I forgot to tell you that earlier, or Control Enter if you're on a PC. And it will create a histogram of this data. We could also create a box plot just by typing boxplot $actual. And it creates a dot plot or a box plot. And you might be more used to seeing box plots turned in the horizontal direction. If you want it that way, you just add an argument here, horizontal equals true. And Command Enter, and it flips it the other way for us. Okay, but if we want to do things that are a bit more complicated, or if we want to actually use a dot plot here, then we need to start using some different things from a package called ggplot. And ggplot is sort of a standard that people use for lots of graphics. Is extremely popular. And to do this, you'll need to run a function called install packages. You start typing it, it'll come up here. And then in quotation marks, type ggplot2. Run that. That will install the package. And then I already have it installed, but then you need to load the package. So library function and then ggplot2. You don't need quotation marks this time. And then we can load that, and now we're ready to start. So to start off, what we want to do is start off just with the function called ggplot. And we first want to tell it the data that we're pulling from. So the data set is called D. And then we want to tell it the aesthetics that we're going to add to it, which in this case is what is the variable that we want to add, that we want to pull from that data set. So I'll just type x equals actual, and you need to type it in all caps exactly like the name of the variable here that we looked at. And that's all we need to put there. And then we're going to put a plus symbol. and we're going to add layers. So everything after this is just adding different layers to the plot and changing things about it. Whereas in base R, you would sort of use a single function and work inside out and have all these different sets of parentheses everywhere. And it can get a little confusing trying to keep track of it all. This makes it a little more clean. So now we want to do a dot plot in this case. So we just type geom underscore dot plot. I'm just going to hit tab. And then we could just leave it like this and see what happens. So if I just run it like this and wait for it to load, then we see a dot plot. And it does look a little bit different than the dot plot that we had in CODAP. But for the most part, it looks the same. There's some scaling things that are different here. This along the y-axis, the x-axis, the horizontal axis, and then the vertical axis actually has a scale, but it doesn't seem to mean much. And part of that is because of the size of the dots. So that's kind of meaningless scale, and we could tell it to change that size of the dots by using what's called bin width. So if we tell it bin width is 1, it will make the dots the size of 1, kind of like it would if it was a histogram. So if we run that, you'll see it's going to change the size of the dots, and this looks a little bit better. And the scale changed here again along the horizontal axis, so we'll have to adjust that if we want it to look like CODAP. Another thing that we want to do is we can then add a box plot to this and overlay it like we did in CODAP. So to do that, just simply click plus, geom boxplot, and then we could just run it like this, and you'll see what's going to happen here. We run that, and it puts it right there at 0. It centers it because we didn't tell it where to put it. So it just put it right there at 0. So we need to tell it where to put it. And to do that, we first need to tell it an aesthetic, which is that we're going to shift it up to, let's say, y equals, let's say we want to put it at 1.5. And we also want the width of it, which is the height of the box. Width equals, we'll say 0.25, because that scaling is pretty small here, right? So let's run that, and we can see what it looks like, and we may need to adjust it. So there it is, and we have that right above the dot plot. Looks nice. Still doesn't look quite like CODAP does. So something else that we'll want to do is maybe we want to add to this the standard deviation. And to do that, we need to create a couple of things first. So we will use a function called geom rectangle. Basically, we're going to create a rectangle, and then we're going to color it a different color. So, but first, let's see if we can create we need to create the positions of the rectangle, the minimum and maximum values, basically. So the first thing that we want to do is create some, I'm just going to create a variable called standard deviation below. I'll just call it SDBL. And in this, I'm going to store the mean of the actual, minus 1 standard deviation to get the lower end of that range of the first standard deviation. So the minus 1 standard deviation, what's the value there? So we have to type in mean of d $actual, and we have to add an argument to this. This means what to do with NAs, or missing values. So one of the things that you may not have recognized is that in the actual, there are actually a lot more values in the predicted column than in the actual column, because people asked multiple other people what their predictions were. And so that means that the values that were, the cells that were empty in the CSV file, when they got imported, they got imported as NA values. So we're going to tell it to remove those. So na.rm means na remove, and by default it's false. So we're going to tell it true. And then we're going to subtract the standard deviation of that same thing. And once again, na.rm equals true. And you can just type t instead of the word true if you want. Okay, so that's going to store that into the standard deviation below variable. And then we need standard deviation above. And we'll do the same thing. Except this time we're going to add it. So I'm actually just going to copy and paste this and change that to a plus symbol here. And now we have that. So now we're ready to deal with the geom rectangle. So the first thing that we need to do with the geom rectangle is add some aesthetics by telling it that we want the x minimum to be the standard deviation below variable. And then we want the x max to be the standard deviation above. And then we also want to tell it how far the y values should go. So we got the x direction, the horizontal direction is between these two. How far should it go this way? So I'm just going to tell it to make the y min be 0, and then the y max be infinity, and capital I lowercase nf means infinity. Then we'll close that set of parentheses for the aesthetic. And we can deal with changing the color in a minute. But first let's run this and see what it looks like. Did it work? And there we go. But it's covered it up. We can't see it. And so now we can start thinking about how to change the colors, the way things look. And that's actually fairly easy to do. So in terms of the actual dot plot, in CODAP, the color was sort of an orange-red color. So we can change that up here in the dot plot function by just saying fill. That's what color we want to fill it with. And I'm going to type orange-red. And we also want it to be somewhat opaque, because there's going to be all these different layers of things on top of each other. And in ggplot, that's called alpha. So we're basically going to make it transparent by 70%. Drop it down to 70%. If it was at 0, it would be completely transparent. So we'll do that. The box plot, if you remember in CODAP, the box plot was also like an orange-red fill, but it was a lot lighter. And and when you type the word color, it puts that's the color for the outline of an object in ggplot. So I'm going to make the color be red because the outline of the box plot was a little darker. And then I'll say fill equals orange red again, and then we'll make alpha be 0.3. So it's quite a bit more transparent. And then, or faded maybe is a better word. And then for this standard deviation here, we can simply make this, it was kind of like a purplish color. So in this particular function, I think we can make the color be purple and the fill be purple. I think both of those were probably about close to what it was. And then fill is purple, and it's quite a lot more faded. And we want to be able to see through behind it, and the colors behind it pop through easily. So I'm going to make alpha here 0.01, and that sounds like a lot smaller, but if I make it any darker, it's not going to come through quite right. So then the other thing is, well, let's run this and see what it looks like. So we can see it's starting to come through. Okay. And you can tell, like, we could even make this probably lighter, the purple here, lighter. So the next thing that we want to do is maybe we want to add the mean and the median lines, like in CODAP. So here we can add what's called a vertical line, V-line, geom V-line, makes sense, right? And the way to do this is to tell it the x-intercept. So in this case, we'll say the x-intercept is the mean, the actual. Don't forget to add in to make this argument true in a.rm. And in CODAP, the mean was a blue line, so I'm going to tell it color equals blue. And I'm probably going to want to make this bigger. Obviously, I've done this before, but to make the line show up a little bit better, I'm going to make the line a size of 1. By default, it's a half. So let's add that and see what it looks like. So there we go. There's the mean. And then maybe we also want to add the median to this. So we can just add another geom V-line and tell it the x-intercept equals the median of d $actual na.rm equals true. And the median was red in CODAP, so we'll make that red. Also make it the same size. And run that. And we get the red line added to our plot. And so far, this is looking pretty good. Now we can add some other things. So the background is gray. We want to get rid of these things on the left. The vertical axis, maybe we want to add a title to this. So the first thing we could do is add a function called theme underscore BW for black and white. And we don't need to add any kind of things to this. Basically what it does is it removes that gray background. So you'll see once I do this, the gray background is gone. And then maybe we want to add a title. So we could say labs for labels, title equals, and I can just say raisins per box. We want an X label too, so X label. And that should just be a number of raisins, I guess. And then the y-axis, we don't want a label there. We can remove that. It's meaningless to us. So ylab, we could just put parentheses and nothing in it, and it will print it empty. We also want the y-axis to not have those values or tick marks on it, because those are meaningless. So to do that, we can use a function called scale y discrete. This allows us to change the values, and it forces them to be discrete. But in this case, we can just say labels equals null, and breaks equals null. And that will delete them completely. It won't print anything. And then on the x-axis, we want to show more values. So in CODAP, these went up by 2. So I would suggest, so we can use scale x discrete. Whoops. And say, or sorry, we want continuous, right? It's not discrete. Continuous. And we can say breaks equals, and we want a sequence. We can just build a sequence here. Starting from 28 and going to 42, which is the min and the max of this specific variable. And we want it to go by 2s. So 28, 30, 32, 34, and so on. Okay. And then the last thing that we might want to do is change the look and feel of the actual text. So to do that, we're going to change some things about the theme. So first, plot title, and we use a function called element underscore text, and we can say horizontal justification equals 0.5. This centers the title, and then maybe we want the size to be 24. So we put size 24. We're not done though, so just go outside that set of parentheses, and I'm just going to paragraph down to make more space here. So the other thing is all the other text. So element text, and we want the family to be Times New Roman, so we can, that in ggplot is called times, and the face, we could make it bold, so the text will be bold, and then color can just be black. And it was some British people who made this, so we're using a British spelling of color in this case. Color equals black. All right, and now we've added these other smaller things to it. The first pieces were pretty simple to add, the box plot and the dot plot, and then adding some color and making things visible through each other by making them a little bit more opaque or faded, transparent. Adding some vertical lines, adding this rectangle to see the standard deviation. And then just adding labels, changing the way the plot looks. And let's run this and see how it looks. And we get this image, which looks pretty similar to what it looked like in CODAP. So you can be the judge of that, but I hope that you found this helpful in learning a little bit about R, as well as thinking about how to transition from using something like CODAP to recreating similar visuals inside of R, and using ggplot as a powerful tool to do that. Thank you.